Close your eyes for a second and imagine a graph, not the boring kind from high school, but living warm curve that changes with pressure, angle, time. Now, imagine that curve is a map of the inside of a vulva, the vaginal canal, and the mysterious little bump on the front wall. Some people call the G-spot. If you like math, or if you just like learning smart ways to explore, this is for grown-ups only, 18 plus. Ready? Let's take a 3-minute joyride where calculus meets curiosity. Think of sensation as a function. Pleasure equals f of x, y, t. The inputs x and y are your variables, pressure and angle, and t is time. You need the rhythm. The derivative f tells you how pleasure changes when you nudge one variable a tiny bit. A small change in angle might cause a huge jump in delay. That's a steep derivative. A tiny change in pressure with no result. That's a flat slope. The trick of exploration is to take small steps. Measure the change and follow the gradient. It's hill climbing, but consensual and fun. The G-spot is often described as an area rather than a single dot. In calculus terms, it's a region where the function has a local maximum, a sweet plateau that responds to certain slopes and rhythms. Not everyone has the same peak, and that's normal. Some people find a clear summit. Others have rolling hills or several smaller peaks. Think of it like different functions. Sine waves, gentle parabolas, jagged peaks. There's no single correct equation. Integration is the math of accumulation. Stroking a tiny region slowly and with attention is like taking an integral over time. The area under the curve builds, and sensation accumulates into something greater than the sum of single touch. Long, steady input can be as powerful as sudden peak. Try different kernels light, firm, steady, pulse, and add them up. The integral will tell you how much total sensation you've delivered. Critical points are where f of equals 0. Those are plateaus, pauses, or peak. When you hit a plateau, don't panic, change a variable. Try a new angle, increase or decrease pressure, alter tempo. Think of partial derivatives. Vary rhythm while holding angle constant. Then switch. Multivariable calculus is basically communication. One person adjusts one knob, the other watches the response. Feedback is the derivative you most want to follow. Limits and continuity teach patience. Approach a spot slowly, like approaching a limit. Sudden jumps can overshoot the sweet spot. Tangent lines hint at angles. Sometimes a slight tilt finds the best contact. Curvature matters too. A curved touch follows anatomy better than a rigid perk. Parameterize the journey. Map responses in a simple notebook or in your head. What worked at 2 centimeter depth? What felt good with a shallower touch? What time of day felt different? Finally, optimization is not a single algorithm. It's playful testing, honest feedback, and consent as your constraint. Safety, comfort, lubrication, and trust are your boundary conditions. Some experiments will reveal a clear maximum. Others will show that pleasure is diffuse and shared. So if you're curious, become a gentle scientist of sensation. Take small steps, measure the change, integrate experiences, and optimize together. Calculus gave us tools to understand change and accumulation. And with curiosity and consent, those same tools can turn anatomy into a map of discovery.